Okay, so this is the definition of voltage. You can either call it voltage, the symbol is V for voltage, right? It's a capital V. You can either call it voltage, you can also call it potential, right? In fact, oftentimes people use the word potential just to avoid sounding redundant. We could say, what is the potential in volts, rather than saying, what's the volts in volts, right? Okay, the definition of it is that it is the amount of work, okay? This is the amount of work, and therefore, by the way, the amount of electric potential that exists, right? And I wish they'd use a W, because people confuse this E. This is supposed to be change in energy potential, right? Per unit charge, okay? So for example, if I'm moving positive charge, let's suppose I've got a negative plate here and a positive plate there, right? Let's suppose I've got 2 coulombs of charge, right? And I move it from the negative plate where it wants to be, and I lift it all the way up there, right? And let's suppose that's 2 coulombs, right? If I move 2 coulombs up there and I do 10 joules of work doing that, okay, that's how much energy I put in, then it has 10 joules of potential energy. And the voltage from this plate to this plate, the voltage difference must be 10 joules per 2 coulombs, which is 5 joules per coulomb, or 5 volts. Or you can say 5 V, right? Okay, but a volt, 1 volt, equals 1 joule per coulomb. Ta-da. Ta-da. It's how many joules of work are done on a coulomb of charge. So let me just do another example here. Oh, let's erase, right? Voltage is also like pressure. The more potential difference there is, the more current is going to flow. And we'll talk about that in the next chapter, right? For air, for example, if there's a pressure of 10,000 volts over an inch of air, well, that's just too much. If it's dry air, it'll break down at 1 atmosphere. Okay, so let's do this one. Hans Full does 0.012 joules of work on 630 microcoulombs of charge. What's the change in voltage? Well, change in voltage is change in potential energy divided by charge. Okay, so the change in potential energy must be the work that we did, 0.012 joules. Okay, and then the charge is 630 E minus 6 coulombs times 10 to the minus 6, right? So let's go 0.012 divided by 630 E minus 6, and I get 19.0476 joules of work for every coulomb. And we only have 2 sig figs, so we have to round it off to there. Yay. So these are pretty easy.